Underneath just about everything you do every day, flipping a light switch, getting a glass of water, even the food you eat, there's this invisible layer of data, a whole set of hidden maps that are secretly organizing our entire world. So let's pull back the curtain and see how it all works.
Just stop and think about it for a second. We've got billions of people packed into cities, all of them needing power and water and internet. We have these massive, sprawling grids and pipelines that cross entire continents. How on earth do we keep all of that running?
Well, the answer isn't just about building more stuff. It's about being way, way smarter with everything we already have. And that smarts, that intelligence, it comes from knowing where things are, how they all connect, and what that all actually means. And this, right here, is the key. It's called geospatial intelligence. And it's not just about, making pretty maps. It's a whole new way of seeing the world. It's about taking all these messy, complex layers of location data and turning them into a clear blueprint for what to do next. Okay, so how does this actually work? What are the tools in the toolbox that unlock this incredible power of where? Let's break it down. It really boils down to these four pillars. First, you've got GIS, which is kind of like the brain of the whole operation, analyzing all the data. Then there's remote sensing. That's the eyes in the sky, all the satellites and drones gathering information. You've got GNSS, which you probably know as GPS, giving us that exact pinpoint location on the map. And finally, LiDAR, which uses lasers to build these incredibly detailed 3D models of the world. Put them all together, and suddenly you have a powerful new way of seeing everything. All right, let's see how all this tech actually builds something real, something tangible, like the very cities and towns that we all live in. This isn't just abstract theory. This is the actual blueprint for our communities. And it is super practical. Planners use something called suitability analysis, where they layer all this data, things like soil quality, flood risk, elevation, to find the absolute best spot for a new neighborhood. They manage zoning with these cool interactive maps, and they can even model future growth to figure out, okay, are we going to need more schools or hospitals in this area 5-10 years from now? But here's where it gets really mind-bending. What if you could have more than just a static map? What if you could create a dynamic, real-time, living, breathing copy of your entire city? Well, that's what we call a digital twin. It's a living model of the city, and it's being constantly fed real-time data from sensors all over town. So we're not just talking about a map of roads and buildings anymore. We're talking about a map of traffic flow, of energy use, of water pressure, all of it updated second by second. And the impact of that is just huge. Think about it. Before this, managing a city's assets, every single fire hydrant, traffic light, sewer pipe was a total mess. It was all scattered paper files and just guesswork. Things got fixed after they broke. But now, with GIS, every single one of those assets is in a digital inventory. You can track its condition, its history, and do proactive maintenance before something fails. It's a total game changer. Okay, so let's follow those invisible networks for a minute. The ones that power our homes, that connect our phones, that deliver our water. This is the absolute lifeline of modern society, and it's all managed by these hidden maps. You know when a big storm rolls through and knocks out the power? And then, for a lot of us, it's back on in just a few hours. Have you ever wondered how they do that so fast? Well, that speed isn't magic. It's geospatial intelligence at work. Here's a look at how it works for electric utilities. For asset management, they create a digital twin of the entire grid. Every pole, every transformer, every wire is on the map. When an outage happens, the system integrates with smart meters to tell them the precise location of the break, so crews can get there immediately. And for prevention, they use satellites to spot trees or vegetation getting too close to power lines, helping to stop wildfires before they can even start. And this exact same logic, it applies everywhere. Water utilities map their whole network to find tiny leaks and save millions of gallons of water. Telecom companies analyze population data to figure out the perfect spot for the next 5G tower. And energy companies monitor thousands of miles of pipeline to keep them safe and plan for any emergency. But the scale gets even bigger than that. This technology isn't just for managing human-made systems. It's actually one of our best tools for understanding and even protecting the natural world itself. Let's take something like wildfire response. First, GIS layers all the crucial data together: the terrain, the type of vegetation, which is the fuel, and the current weather. That creates a map showing the high-risk zones.
Then it can run simulations to predict how a fire might actually spread. With that kind of foresight, authorities can plan smarter evacuation routes and get firefighters to the most critical spots.
And one of the most powerful tools for this is something called NDVI. The easiest way to think about it is like a health check for all the plants on our planet, seen from space. Satellites can measure how plants reflect light, and this index can show if a forest is stressed from a drought or if a farmer's field is being hit by pests, often long before you could see it with your own eyes.
And this has led to a complete revolution in farming. The old way was, you treat a whole field the same. You sprayed the same amount of water and fertilizer everywhere. But with precision agriculture, farmers use these NDVI maps and GPS-guided tractors to give different parts of the field exactly what they need. A little more water here, a little less fertilizer over there. It saves a ton of money, you get bigger yields, and it's so much better for the environment.
And get this, it's not all just a flat picture on a screen. All of this data can be visualized in stunning 3D. We can create these detailed models of everything from underground ore bodies for mining companies to the complex, intricate canopy of a rainforest. It gives us a whole new dimension of understanding. So, when you put all of this together, what's the big takeaway? What does it all mean? Well, it means we are fundamentally changing how we see and interact with our world. There's this quote that I think just nails it. We don't just map the world, we redefine how it's understood. We're not just making better maps anymore. We are gaining a deeper, more dynamic, and even a predictive understanding of the incredibly complex systems that support all of our lives. So, the big picture is this. We're using this intelligence to build smarter cities. We're making our critical infrastructure more resilient. And we're getting powerful new tools to farm more sustainably and protect our planet. At the end of the day, it's about transforming raw location data into real, actionable, predictive insight. And that leaves us with one last big question to think about. As this technology gets more and more powerful, as it starts to map not just every place, but every object and every action, what will it mean to live in a world where, for the first time in all of human history, there is truly no uncharted territory?